You know, this gaming mouse right here, can you see it? Is really good example to understand what algorithm is. And not just algorithm, there are few buzzwords around this algorithm, like pseudocode. Then there is algorithmic analysis, there is asymptotic analysis, such a big word, isn't it? Then there is big O, then there is word scale. So we'll see, one by one, each of these words, what these means. But with this mouse, to understand algorithm, there's like, it's a good mouse, like, no doubt, like, it's a good mouse, like, lighting is good, great, it's a breathing effect, like, everything is there. The sensor is also good for gaming purpose and for all the tasks, could be. But if you're gonna hold this mouse in your hand, you're gonna say like, there's some problem with this. And that is, it's weight proportion, I believe so. Because for a day-to-day task, I think it's a little bit on a heavier side, which usually is not preferred. And even for gaming purpose, I don't think it's preferred. So you might gonna ask me, hey, like, can we design our own mouse, or own gaming mouse, which is more comfortable, which has like a design which doesn't gonna sweat the palms during the game, intense gaming moment. And I was like, yeah, we can start. So the very first statement that you told me is, let's try to design our own gaming. And that's the very beginning of an algorithm. That is the beginning of an algorithm. So you put a very first statement, and if I don't know how many of you went through the video of logic and proof, over there what I discussed is that in logic and proof, which is the theoretical part of the mathematics, what we do is we try to create complexities of our statement with the help of negation and operator, or with connectivities, conjunction, disjunctions. Like, these are too many words, but I have discussed, I have explained these things in a very layman terms over there. So we not started creating these complexities. And with the case of a mouse, a gaming mouse, I think the complexities is gonna be like, what could be the material. So we haven't see we haven't went into the details of what we're gonna do, but we starting to picturizing that what we might gonna do in the near future for designing and creating this mouse. So the first thing would be the material. Second thing would be the sensor, because sensor is an important part. Third could be the RGB lights. I mean, why not, when everyone loves RGB, when it's all about related to gaming. So in computer peripherals, RGB is a must. So these are, I think, the few things, but we haven't started analyzing a lot of things. And that's where algorithmic analysis starts to come into the picture. What does that mean? So let's try to hop into the on the screen, and let's try to understand from there. Oh god, I again well, let me put my drawing tab with my machine. Okay, so it's working now. Let's try to understand what I mean exactly by that. So for example, let's take the very first statement. Let's hopefully my writing is not that bad. Design a gaming mouse which is comfortable. Let's design a gaming mouse comfortable, a must. So this is our very first statement. Let's try to, like, could be the material. We haven't decided what it could be, but we might have left a little bit of space around that material so that we can fill in what sort of material we're gonna use. How, what could be the density of that material? That means how much of the micron. Micron plastic is being measured in micron. What micron it is? It's mu, actually, mu for micron. And what could be that? Then there could be, could be, let's say, lighting, that is RGB. We haven't decided anything yet, but like, there are so many things which we need to fill into this. Then there is there could be a sensor, important part. And there are further other things which we can write down here in our native language. So lighting could be there. Now if you pay a little attention, so for example, there is micron material, just leave it. Let's try to focus on lighting and RGB lighting and all these things. So in order to have a good gaming mouse, it needs to be wireless, because wired one kind of started having a little bit of a problem when it comes to playing intense game. So for example, if you're designing a wireless mouse, so the biggest problem which you might start in discussing, or putting your brain to work on it, is efficiency of the battery, or the battery life, because you don't want to put a lot of batteries into it, or you don't want to put every time to its into charging. by with every few hours of working. You don't want that. So energy consumption is a main concern here, and this correlates highly with what lighting. And that's how you start seeing that we started getting into more of a complex thing right here. This is what exactly algorithm is, and this is exactly coming directly from logic and proof, where we started creating complexities of our own statements, and we try to form our logic and try to achieve a logical proof, which could be anything. So basically an algorithm is going to be a finite thing, which is also yet another property of a function. Functions are also finite. Logic and proof is also finite, because you cannot, and you just cannot leave any of statement. You need to prove something. So proof becomes really important, and in this case it's the designing and being able to achieve, being able to create a gaming mouse. So let's try to hop into here and let's try to see it again, what these complexities are. So energy consumption and wireless has a dependency on this, and this has a dependency on lighting. So since you want to make it efficient with energy and the electricity of the consumption of the electricity, what you could do is that instead of running the RGB lighting, you could say that, hey, let's turn off RGB maybe after 30 seconds of not using. And that is exactly what your mobile computation devices also do. Computation, let's just leave it. Your mobile, your smartphones also do. They kind of have a have a their ticking time which is going on, and it calculates, hey, okay, so my screen has already wake up to this time, let's try to save the battery and just turn off the display. That's how like this is exactly what the intuition here is. So you started seeing that we started getting into these complexities, their dependencies, conjunctions, disjunctions. This is what an algorithm is. This is exactly what an algorithm is. The complexities are there. And let's try to understand a little different intuition, which is something called a pseudocode. Pseudocode. I think I hopefully I wrote the so what pseudocode is, in logic and proof, what we did is, instead of writing the statements all the time, what we did, we kind of mapped them to some variables with the help of function. A function is something which maps, a function is a mapping thing, it maps. So we started mapping our statements with variables. And what I mean by that, let's try to look. So here, what we can do is we can assign a variable p here for the material thing with q, and there could be like other variables like q1, q2, anything. It depends on the situation. We maybe like designate a variable r to lightning, RGB to sensor, maybe s, anything. So let's try to focus on this thing here, because we gotta have wrote down a little bit more here, and it has a little bit of dependency. So a pseudocode could be, I will explain it with an example also, but let's try to understand what's here. So here we are having a lightning RGB, and let's try to turn off it at every 30 seconds. So what we have to do, if we started writing, so it could be like if RGB light underscore light. It's a good way of writing variable names in programming also, so it's a good practice. Try to we already have started with programming. So if RGB light is greater than 30 seconds, can we write this statement like this? I think we can. I think you do understand this. Like we just converted this thing into this much of thing, and there is these statements are coming, and then there is below a few more statements related to sensor and all of this thing. But let's try to turn it off, and as soon as that happen, RGB light becomes zero, maybe null. And as soon as the movement occurs slow, you can start it creating more and more complexities here. So if movement if movement occurs, then RGB light equals to 1. I'm saying just 1 for high and low current. 1 means turn on. Why 1 and 0? Because in computer we only have ones and zeros, and these are nothing but high voltage and low voltage, nothing else. We'll see when we'll touch the memory. I'll explain a little bit more about these things, high and low, because they are highly correlated with memory. Before starting writing any sort of code, any programming, anything, we're gonna see memory, and I think afterwards a little bit of the function, because that's gonna lay a really good foundation to understand what programming is in general. So let's try to understand with another example what pseudocode is. Pseudocode is nothing but converting these statements in your native language, in any language, to some sort of a variables thing, so that we don't have to write a lot of statements again, which kind of helps to eliminate a lot of problems, bugs, any sort of those things. That's it. That's what pseudocode and algorithms, that's the only difference between these two things. Usually people kind of mix these two things, which by the way isn't wrong exactly, but they kind of have a little bit of differences. A pseudocode is written in a format which you can also read, and which you can write down into any other programming language with the help of these variables and these shorthands. While in algorithm you have your own language, a detailed version of your what you're going to do in your own language, maybe in any other language, it depends. But that's what and difference between an algorithm and a pseudocode is. Let's try to understand pseudocode and algorithm a little bit more with another easy example in mathematics. So let me try to put this a little down. Let's try to understand with an example. Let's say that I want to make addition of two numbers if and only if there is at least one of them is even. Okay, so let's take two numbers. Let's name them as n1 and oh, I wrote my and as like this, n1 and n2. Sorry for my bad writing. And let's take two numbers, and if any of them is even, add them. Okay, so let's try to convert this in a pseudocode. Let's say input n1 and n2 if any one of them, so n1 mod, that's a modulo operator. Actually it kind of traces the remainder, like if you do 3 divided by 2 regarding 1, that's what it is catching. So that's the case of an odd always going to leave with 1, and if it's an even, if say like 2 dividing, so it's 2 again, then dividing again 2, so we left with 0. That's a case for even. Okay, now n1 mod 2 equal 0, which is like checking, or maybe equals to 0 while checking. Okay, or n2 mod 2 equals 0. If any of them is divisible by 2 or is even, then n1 plus n2. That's it. So instead of writing all of this, we can like convert this into this, and that's what a pseudocode is. Pseudocode, that's it. I think hopefully I wrote the right word. So that's what a pseudocode is. Okay, so we have discussed algorithms, we have discussed analysis. See, with analysis, what we try to do is, we try to optimize it. We try to start looking into the details. What we did is, for example, we just decided with material, but when we started really looking into it, what could be the material? What could be the size? How much of the thickness? With lighting, you see, so if we are designing a wireless, then the energy consumption is there, then its dependency, how much energy is going to consume. Then there is also sensor, then calibration of sensor, a lot of thing is there. So we started analyzing, and what we're gonna do is, what we are trying to do is trying to optimizing it, so that we don't have to do a lot of unnecessary tasks. That's it. That's what we are doing with analysis of an algorithm. We wrote down our steps, but hey, can we improve somewhere? That's it. So next thing is actually is trying to understand what big O or the asymptotic analysis is. Since we already saw what algorithmic analysis is, we'll try to understand what asymptotic analysis. Asymptote is nothing but a word. Let me try to asymptote. I think it's the right word. I don't know. So asymptote is basically a line in a plane. A plane is a field where mathematicians could just by looking at the curve can tell which equation it belongs, or which family of equation it might belongs. So it is a curve. If for example there is a line going like this, so asymptote is a line. If it has reached, a certain point, it's a break even point, you can think of, or maybe a threshold. And if it started, going up, it's always going to be parallel. It's never going to meet, never, even to the, infinity. It just started going up. That's what an asymptote is. Sometimes asymptotes, started going like this. Oh god, wait. I think it's a little bit more closer, but for instance, it just goes along with, y plane. It never gonna touch the y plane if it's going to parallel to is. It's like a parallel line, but that's what an asymptote is. It's never gonna touch this line ever again in any of upcoming future, never. So that's what an asymptote is, and that's from where it is coming from. So asymptotic analysis of big O. Let's try to get to some another example. Let's say your mom. God. So your mother has told you to buy some, product or maybe a commodity from, a market. And usually my mother also, sometimes sent me also outside, just go and buy this thing. I want this right now. So usually what happens is that they're always going to give you a really fixed amount of money. It's never going to be like a little bit more. I don't know how they just know the price of a product, and not being, been outside to the market for a really long time. I don't know what sort of supernatural power that they have. But for example, let's take the example that the product somehow cost around 50 rupees, and they're only gonna give you 50 rupees. They're never gonna give you like 60 rupees or anything else. So you started thinking, and let's take some constraints here, that UPI or the digital transaction is not there, or maybe the shopkeeper doesn't have any sort of digital transaction, and you just have to go and buy there. And it's a little bit far. So in case you left with a less amount of money, and if the price of the commodity has gone up, you have to return back to the home, and then you just go up to, just have to rent again. Okay, so you started thinking as soon as she said, like, just go and buy this, and you'd be like, hey, wait, inflation is going there, and it's a real world, not an ideal world, so the price might go on up, might, it's a higher chance always, even if you look at the price of the Maggie, it's already has gone like really up in few years. So you already have decided, let's try to take an approximate how much heights might have gone. Maybe, so if she's saying 50 rupees, let's try to grab at least 60 logically, maybe 80, or maybe 50, maybe 100. That is much more logical approximation. And that's what you take. You're not gonna ask your mother like, give me 1000 rupees to buying a product of 50 rupees, because you're gonna scold it by her. And we nobody likes it, man. Like, nobody likes this that sort of drama, to create that sort of drama over there. So you you got an idea, you got an approximation of somewhat around 100 rupees, which is the twice of the 50 rupees. So that's what an approximation, that's what an asymptotic analysis is. It's an approximation, to be precise. And what we are doing is a logical approximation. It's not like we're trying to, push the boundaries to any value. It's like it's remaining into the boundaries of that logical, thinking. So if the price is somewhere around 50, how about 60? How about I take 60? Or how about I take 80? Or maybe you might be lucky and the price might, for you, just because you were the luckiest customer, maybe you were the 5,000th customer for that shop, so they might have given you a good discount around, like, maybe instead of taking you 50 rupees or 60 rupees, they might have asked you to just give 20 rupees. Why not? Like, the possibilities could be there in real world. So now you started seeing something here with the value of 50. You started seeing that it might have gone up, it might have gone down, it might have been stayed somewhere around 55 rupees, or maybe some discount might have come into the market because of some, anniversaries there, or jubilee anniversaries there for the company, maybe 52 rupees, they have slashed like 3 or 2 rupees. So now you started seeing some sort of variations with this 50 rupees of the, price of that commodity or the product. So that's what, like, let's just start it. Look, let's try to look into the screen. Let's try to understand what I mean by this. So You went to the market and you buy a product, and your mother said, "Hey, it's around 50 rupees, yay!" But you be like, "Hey, wait, I don't want to come back again. Like, it's gonna waste my time. I was already watching my Instagram reel, which is such a big task, which I'm doing." So you be like, "Let's think." So you're thinking, and boom, you be like, "Hey, inflation is there, it's real world, so the price might have gone up." Okay, so the price might have gone up, probably will. So you'll be like, it might be around like 60 to 70 rupees. Let's why not take an approximation of 60 to 70 rupees? Why not? It's not gonna hurt us. And that is something called a big O. And you'll be like, "Hey, why are you silent?" So actually, this big O is an asymptotic analysis. It's a line, you see, it's not gonna touch it, and it's above, so it's on the upper side, and that's what big O means. And actually, this O is a German word. I have wrote down. It means Ordnung, Ordnung. Nung, Ordnung. Same the word null coming from German language. So it is coming from German language. And this actually means approximation, the order of approximation. So what are you doing here? If you look at the example of mouse, of our mouse here, you notice that the companies, what they do is they always gonna tell that this has the clicks are around 1 million clicks up to 10 million clicks. Same goes with tire advertisement, like it's gonna stay for around, like, for these many thousands of kilometers or millions. I don't know, man. So thousands, hundreds of thousands of kilometers, it's gonna stay up till there. So there's always an approximation. For example, efficiency of a fuel efficient bikes, they always claim 90 kilometers, 95 kilometers per liter, which we all know, like, it's gonna stay up to 80 or 70, but like still it's like really big, big mileage as compared to the efficiency of that sort of tiny engine. That's a good thing. But you see, the value of approximation is different, the value in real world is quite different. I think you getting the point. And like there are a few other things, like let me tell you. So for example, there is this, and you also notice what I told you, that there is the price might have come down just because you might be lucky customer, so they might have given you a discount. So instead of 50, you might ended up paying around, like, what, maybe 20 rupees. Like, so you just went there and you ended up paying 20. And this curve kind of represent, I think, what it might represent, maybe money and what, inflation, price, and what could be the hey, wait, let me think. I didn't think, oh god, I didn't think about this. What the, so that could be, with time. Oh yeah, it's a time, so you're gonna spending time with price. Oh yeah, okay. So okay. So this represents price. So the price is going up or maybe it's down, and with time, so it's increasing with time. So what this line represents, it's the best case for you, because you're just paying only 20 rupees, and rest 30 rupees gonna end up with momos or maybe anything. Okay, so that's the best case, and it is represented with the omegas. So called big omega. Okay, this basically represents a best case. It's a best case for you, man. Come on, you you're getting a discount, so it's a best case for you. You can buy anything. And then there is something also called as an average case. You see, the price might fluctuate in between there, and maybe the company has given a few discounts just because they have their anniversary going on, anything like that. So it might end up like up to 50 rupee. Oh no, not 50, sorry, it's 45 rupees. It's now becomes 450. What the, so now instead of 50, let's say maybe 48 rupees. And maybe in case it might have increased, maybe you are not that lucky, so could have went up to 55 rupees from 50. So this thing is somewhere called, you can see that from on lower side it is holding from upper side, and this line is not never gonna touch these two lines ever again. And this is called theta, big theta. It's called the average case. You see, it's kind of average of 50. If you add these two these two values here, it gonna average somewhere here, it's gonna drop somewhere here. So it's called big theta, it's like at the average. And so, the best case for you for momos, yay, is good. Why the best case? Sometimes you actually need to know that till how low for the input value in algorithm, all these things. Oh, I'll tell you, is it's never gonna go below that. So sometimes you might also want to know. That's why the best case is there. And as I think you got an intuition or the idea that what I actually was trying to explain is that approximation and real world things are different. So your big O notation, usually what people try to correlate them, they both are representing things like, no, a big O is a little bit different. It's an approximation, it's a theoretical value, it doesn't exist in real world, but you try to create an intuition, a logical approximation of a particular task which you're trying to do. So you'll be like, let's take a safer side, let's see that how worse it can go. The case how you always take these approximations with everything. So if you're going outside for for travel, if you're traveling, if you're going to gonna visit some cities, you always take a little bit of a little bit more money, more cash in hand, maybe sometimes medicine with yourself, in case if something might happen. That's an approximation. That's what we are doing here with big O, with all of this. And the real world, somewhere below that, somewhere above that, it's in between both of that. And that's what the worst case is. Worst case might occur in usually occurs in the upper side. So that's why people try to correlate these two terms as same, big O and the worst case are same. Like, no, there are subtle differences. So worst case depend on the real world, on the real world factor. For the case of mouse, it could be temperature, dust particles, shocks, it might have fallen down, all sort of factors are there. So it might have not been able to reach those 1 million clicks as being claimed. So these are the things. Then I think let's oh yeah, there's one more thing, complexity. There's one more word. So let's try to understand what complexity is. And should I explain? Oh no, let me try to explain with this thing. So you see that there's a price thing and there's a time thing. These two are two entirely different things, and these two combined together form a complexity. What complexity? It's a complex of time. Time is a different, entirely different dimensional object. Price is a different dimension, and trying to put these together and trying to map something to take a meaning out of these two terms. So it's a complex. Same goes with algorithm. In machine, you usually see your computer does only one thing. It's storing the data and pulling out and give it back to you with a little bit of computation. So there two basic operations are going on, which is the main one being the main thing, which is storing and giving it back to you, maybe from anywhere, from server, from anything. And the time taken to process that logic, to how it's gonna fetch and how it's gonna store that data for you. So I think you got the point. It's a time and the space. Space means the storage. So there are two things. Okay. So there are two things, and with what? The size of the file, which is the input. So I think you got the point. So here is gonna be the input. Here's gonna be the time in case of time, or space. With number of input, how our time and space is going on. And that's what with algorithms we'll see. This is what we study. That's what in complex is. That's what a function is. That's what everything in algorithms is. That's what we try to study. So in next video, we'll try to understand what memory is, because before writing any code, you need to understand what memory is. We're not going into the details, but we'll try to create an intuition with our own experience, real world experience, and try to understand memory in a way. Just hang with me and, like, let's say bye. So I think first time I'm saying bye in the video.